Okay, now let's look at question number 14, part B of the applied paper. So this is the coplanar forces question. So this diagram is given, and these lengths are A, this angle is pi over 3, and this angle is pi over 6. And additionally, they have said AED, this angle is 90, AFC, so this angle is also 90. Right, so after that, they have mentioned these four forces acts along AB, BC, DC, and AD in the direction of the indicated letters. So let's mark all of them in a diagram. When you do these questions, draw a big diagram. So then it is clear what are the angles, what are the lengths that you want to find. Right. So now let's mark the forces as indicated by the letters here. So force P is in AB direction. So this is P. Then in BC direction you have alpha P, and DC beta P, and AD gamma P, right? So this one is alpha P, this one is beta P, and this one is gamma P, right? So forces are marked, and these angles also will mark. So this is pi over 3, this is pi over 6, right? So this we know 90 degrees, right? So, and what else? This length is A, this length is A, right? Then what else? Okay, if this length is A, this length is also A, and this is what AE is, A cos pi over 3. No, you look at ADE triangle, then AD cos pi over 3 is AE. So this length is what? A over 2, because AE is A cos pi over 3. So that is A over 2. And we'll find DE length also. We will need these to do the rest of the question. DE is what? Again, ADE triangle. So A sine pi over 3. A sine pi over 3. So root 3 A over 2, right? So this length is root 3 A over 2. So this length is also root 3 A over 2. Right. So, right now, what else? So everything is marked up to now. Up to here, we have marked everything. Now it is given that resultant force of these is root 7P, and it passes through EC. So resultant goes through EC in the sense from E to C. So direction is E to C, right? So let's mark the resultant force. Resultant force is that one. So this one is root 7P, right? Okay, so everything is marked now. Now we want to find alpha, beta, and gamma values, right? So we have three unknowns, so that means we have to create three equations. So we can do that using what? Using moments and uh, vertical components and horizontal components of the forces, right? So if you look at this diagram, we can find gamma p if we take moments about c. If you take moments about c, alpha p and beta p goes through point c. So we don't need to consider those two then. Then the only unknown is gamma p. So we'll take moments about c and find gamma. So I'm going to take moments about c anti-clockwise. So let's recall our moments condition. Algebraic sum of moments is equal to the moment of the resultant about the same point. So we will use that. So now no need to think of alpha p because it goes through c. No need to think of bp beta p, again goes through c. So the only forces left is p and gamma p. So p is going in anti-clockwise direction and the moment is what? P times the perpendicular distance, which is root 3a over 2. So P times root 3a over 2. Then this force is done. Only force left is gamma p. So gamma p is going clockwise. So that is a negative moment. Gamma p in this direction. So what is the perpendicular distance? So just extend AD line and BC line. So they meet at a 90-degree angle. Because why? This is 60 no, and this is 30. So this angle has to be 90, right? So let's say this is G. We need to find CG length. CG length is what? CG length is using the CGD triangle, A sine pi over 3. A sine pi over 3, which gives you root 3a over 2, right? So then gamma p root 3a over 2 equal to 0, because why? The resultant goes through c, so the moment of the resultant about point c is 0, right? So then we can solve this equation to get the value of gamma. So this is common, cancel that. P is common, cancel that. So what is left? 1 minus gamma equals 0, or gamma equals 1. So we have gamma value, right? So now we finish with that one. Now we have to figure out alpha and beta. So you can do this in two ways. You can take moments about two other points and figure out alpha beta, or you can use vertical components and horizontal components of the forces. So I'm going to do using vertical components and horizontal components. So algebraic sum of the horizontal components is going to be equal to the horizontal component of the uh, resultant, right? So to find the horizontal component of the resultant, we need to figure out this angle first. So let's look at ECF triangle. From that triangle, we know what? tan alpha is root 3a over 2 divided by a. That is opposite over adjacent. So tan alpha is root 3 over 2. So then this acute angle, no, so I'm going to just draw this root 3 over 2. So then hypotenuse is root 7, right? So we'll use this triangle to figure out the other ratio, sin alpha and cos alpha, which we require to use horizontal component condition and the vertical component condition, right? So we'll use the horizontal component condition. So algebraic sum of the horizontal components is equal to what? Rx, which is the horizontal components of the component of the resultant, right? So we have P and beta P, both of them are horizontal. So in the same direction as this, which is my positive direction. So beta plus, sorry, P plus beta P, P plus beta P. Then from this one, alpha P, the horizontal component is alpha P cos pi over 6 in the negative direction. So you get minus alpha P cos pi over 6. Then this one done, this one done, this one done, this one. Gamma is 1, so that is P. So gamma P is just P. P, what is the component? Horizontal component is P cos pi over 3. That is in positive direction. So plus P cos pi over 3 equal to the horizontal component of the resultant. Resultant horizontal component is root 7P cos alpha. Right. So that is root 7P cos alpha. Now let's find this P. Okay. Before that, we can cancel P. No? P is common to each term. We'll cancel that. So we have 1 plus beta minus alpha root 3 over 2 plus half root 7. What is cos alpha? Cos alpha from this triangle is 2 over root 7. 2 over root 7, adjacent over hypotenuse. So we have 2 over root 7. So simplify, cancel. I have 3 over 2 plus beta minus alpha root 3 over 2 equals to beta minus alpha root 3 over 2 is equal to half 2 beta minus root 3 alpha equal to 1. Right. So let's say this is equation 1. So that is from looking at horizontal components. Now let's look at vertical components. So sigma y, the vertical components together is equal to the vertical component of the resultant. So let's see. So there's no vertical component from P or beta P because they are horizontal. Then from alpha P you get alpha P sine pi over 6, the vertical component, and it is in positive direction. So alpha P sine pi over 6, and from gamma P again positive component, gamma P sine pi over 3. P gamma is 1, so this is P sine pi over 3. That is also positive. So P sine pi over 3 equal to resultant vertical component. So resultant vertical component is also positive, root 7p sine alpha, root 7p sine alpha, root 7p sine alpha. So again we can cancel the common part p, cancel, cancel, cancel. And what is sine alpha? We need to use sine alpha. Sine alpha from this triangle is opposite over hypotenuse. So root 3 over root 7. Right. So we have alpha, half alpha, root 3 over 2, root 7 times root 3 over root 7, which is the sine alpha. Cancel. So multiply by 2. So you have alpha plus root 3 equal to root 3, or alpha equals root 3. Right. So we found alpha equals root 3. Let's say this is equation 2. Oh, then sub 2 into 1 to find beta. So 2 beta minus root 3 alpha. Alpha is root 3 equal to 1. So what do we have? 2 beta minus 3 equals 1, or 2 beta equals 4, or beta equals 2. Right. So those are our alpha, beta, gamma values. Gamma is 1, alpha is root 3, and beta is 2. Right. So that part is done. The next part is what? Now a couple is added to the system such that line of action of the resultant of the new system passes through F. So passes through F. Right. Find the moment of the couple added. Right. So now, okay, this system we have this resultant. Then in the new one, the resultant goes to F. Right. Right. So let's just, so this system we can just erase these forces. All of these together is the resultant. Right. So this is our system. Now the new resultant goes through where? Let's say R dash. This goes through F. When a couple is added to the system. Let's say that couple is G. Right. So now we need to figure out the value of this. So we can do what? We can take moments about F for this new system. So take moments about F, then we don't need to worry about this R dash. No? So the only force is this resultant force, and there's a couple G, right? So we'll do that. Take the moment about F, because we know the new resultant goes through that point. Take moments about F. So then we know we have what? The couple G that we want to find minus or plus what is left, the resultant R. So resultant R is going in clockwise direction, so that is a negative value. So we need to figure out what we are doing it from F. No? So taking moments about F, that means I need perpendicular distance from F. So this length, let's say this length is L. So from this triangle, this angle is alpha, this length is A. So L is what? L is A sine alpha. Sine alpha is what? Root 3 over root 7. So root 3A over root 7 is L, right? So then we can figure out the moment generated by root 7. So that is going clockwise, so that is negative. So roots negative root 7p root 3a over root 7, and then the new resultant moment is 0, no? Because the resultant new resultant goes through F, right? So then simplify and we have the answer. G is what? Root 3 pa Newton meters, right? So that is the size of the moment introduced, the couple the moment size of the moment for the couple introduced to the system, right? Okay, so that is the answer for question number 14, part B.